about the when we talk about the uh, when we talk about the formal charges, right? Why do we need formal charges, right? First, you have to understand that why do we need formal charges, right? Formal charges we need whenever there's a more than one structure of a compound. Is it clear? Understood? Sulfur trioxide comes in your exam, right? Can you send me a message, please?
Yeah.
Sulfur trioxide, Lewis structure, page 191. Important. Practice sulfur trioxide. This comes in exam. Have you written? Sulfur trioxide will be very similar to ozone, right? Ozone. Sorry, sulfur dioxide, my bad. Similar to ozone. Have you written SO2, Lewis structure, page 191? Clear? Mind, as I've told you, if oxygen has got three hands, it will be having one lone pair of electron. This trick I'm telling you. If oxygen has got two hands, it has got two lone pairs of electron. Have you written?
Yeah.
If oxygen
And
has
three.
got one hand,
Three.
it has got three lone pairs of electron. Is it clear?
Yeah.
Similarly for sulfur also, because sulfur is in the same group of oxygen, just below oxygen. Is it clear?
Yeah.
Mind understood this part clearly? Fine. Now, if you
Yes.
see, whenever we are seeing this, right, we can also tell that if we see sulfur dioxide has got two structures, isn't it? One expanded octet structure and one normal structure, isn't it? Isn't it? Which one to choose from? Which structure will be the best to represent? Have you thought of that? How to represent this? We can represent the more favorable structure by calculating the formal charges. Is it clear? What is a formal charge? Formal charge is a apparent charge given. Is it clear? Understood? It is not a real charge given. It's an apparent charge given to all the elements. Fine? Is it clear?
Yeah.
Remember one thing, sum of all the formal charges, right? Sum of the all the formal charges, right? Sum of all the formal charges, they will be adding up to zero. Is it clear?
Yeah.
Understood? Formal charge is what? I told you. Formal charge is the apparent charge given. Is it clear?
Yeah.
It is not a charge. Is it clear? Fine. Now,
Yeah.
what did I say? The sum of all the formal charges will be adding up to what? I told you zero. Is it clear? See, we add up these formal charges, it will be zero because the compound is neutral. Is it clear?
Yeah.
Got this important trick? Fine.
Yeah.
Understood this thing? So this is a very important part we learned, right? Now go to the next part, right? You have to see that when we see the formal charges, what is the calculations we have to do? The calculations we have to do is that in any formal charge, right? What we do? We first write down the number of valence electrons. Is it clear? That's very simple. From the group number, you can find out the valence electrons. Is it clear? Got it? From the group number, you can get the valence electrons. Did you get this thing clearly? Fine. We
Yeah.
can easily get the we can easily get the we can easily get the number of valence electron from the group number. Fine.
Yeah.
Okay. Now, next is what? We have to subtract the total of half of the bonding electrons. Is it clear? Plus number of electrons in the lone pairs. Is it clear? While checking the IBDP papers, I see that the main mistake they do is that they write the lone pairs of electron. Some understood. They put one over here. It should be two. Number of electrons in a lone pair. Is it clear?
Mm.
Clear? Understood this thing? So valency minus half of the bonding electrons plus number of electrons in the lone pairs. Is it clear? Got it? Understood this thing clearly?
Yeah.
Now, over here, can you quickly calculate? See, I'm showing to you. What is the valency? This is
Six.
group number 6. So six number of electrons in the outermost orbit will be 6. Valence electrons 6 minus how many bonding electrons are there? Tell me.
Two.
Where 2? 1,
No.
2, 3, 4,
Three.
5, 6.
Oh,
Clear?
yeah. Six.
6. Half of 6 is what? 3
Three.
plus number of electrons in the lone pair. Is it clear?
Two.
So 2. Is it clear? So 6 minus 3 plus 2. 6 minus 5 is equal to 1. Is it clear? Plus 1. Is it clear?
Yeah.
Got it? Understood?
Understood.
Mm-hmm. Thank you so much. Now, can you tell me that how about the formal charge on this oxygen? What is the valency of group number 6? Oxygen 6? 6
Six and
minus
then
how many bonding electrons are there?
two.
2 electrons are bonded. So 2
Yeah.
divided by 2 plus number of electrons in the lone pair of electrons, right?
Six electrons in
So
lone pair.
Isn't, isn't it? Fine.
Yeah.
There are 6 electrons. So 6 plus
6.
7, that is -1. Clear? We do it -1 over here. Clear?
Yeah.
Understood? Fine. Can you
Yeah.
find out the for formal charge on this oxygen? Can you quickly find out?
6 minus 4/2 plus zero.
Hmm. 0. Is it clear?
Yeah.
Understood how to do it? Easy. Absolutely easy, right?
Yeah,
So,
sir.
so what we do? We put the formal charges, right? Isn't it? Now listen. Which one to take as the more favored structure, Lewis structure? The more forward Lewis structure is where the formal charges distribution is the minimum. Understood? Many people do what? They add up these. Adding up these will be always coming 0. So minimum distribution of the formal charges. This is what? 0 plus 1 minus 1. And this is 0 0 0. So this is the more favored formal charge distribution. Is it clear?
Yeah.
Understood? Clear? Easy? Got it? Fine. Now next is that if you see that when we utter the word, suppose I'm just saying this part. Now, can you do me quickly a favor? Can you write down the formal charges now quickly? Mind? Fine.
Yeah.
Got it? Is it clear? Now see, mine.
Yeah.
I forgot to tell you a question. Do you know what? In your exam, you'll be seeing that noble gases do not form compounds, right? But they form compound like ZeF4 and ZeO3. Why? Huh? Now write down the answer. When you go down the group, right? What happens? The electrons will be the outermost electron will be going far away from the nucleus. Is it clear? Understood?
Yeah.
Clear? What happens? The noble gases do not want to gain or lose electrons because they have got a complete octet, right? But in the presence of highly electronegative elements such as oxygen and fluorine, right, they are sometimes forced to form a bond because in xenon, that is in period number 5, so there are 5 orbits. Is it clear? Fine. So the outermost electron is far away from the nucleus, right? Hence, they can expand their octet and form the bond with fluorine and oxygen forcefully. Huh? Okay? Is it clear to you? Did you get this thing? So
Okay.
fluorine and oxygen will be forming a bond with xenon because their outermost electron is far away from the positive charge nucleus. Is it clear?
Yeah.
Got it? Is it clear? So you have beautifully drawn the formal charges of one example, right? So we are getting the formal charges distribution like this, right? Can you tell me which is the favored Lewis structure? This or this? Tell me. Where the formal
Mm.
charges distribution is the minimum. Understood? Suppose we have got a distribution of +1 -1,
This
and you're getting
one.
a distribution of +2 -2. So this is the favored one. Understood?
Yeah, so this.
Understood? Understood? 0 0 0. Understood? Clear? Easy. Formal charges clear to you? Got it?
Yeah.
Is it clear? Now we're going to the next part, right? Now, if you see when we see now, send me a message, please. Send me a message. N2O N2O Lewis structure and formal charges. Lewis structure is on page 193. Pearson. Have you written?
Yeah.
Have you written this? This
Yeah,
comes
sir.
in exam, right? And one thing also written right in one breath. Just 1 minute. Just give me 1 minute. 26, no? Just 1 minute. Give me a minute. This is 495. Just 1 minute. Just 1 minute, right? 1 minute. Uh, Fine. Send me a message, please. HNO3. In that message only, edit and send. HNO3. Lewis structure. Lewis structure, page 509. Pearson. Have you written? Okay. Understood. Clear? Fine. Mine, can you hear me?
Yes, sir.
Thank you so much. Thank you so much. So we're going to page number 206 again. Now, next thing is that, see, which is the favorite formal structure? Here, both is the same distribution, right? Plus 1, minus 1, 0, minus 1, plus 1, 0. Same formal charge distribution. Now
Yeah.
the important thing comes. What the important thing? We have to pick up that formal charge, right? We have to pick that formal charge where the negative formal charge is on the more electronegative element. Is it clear? Fine. Next law. Carbon, nitrogen, oxygen, fluorine. As we
Yeah.
move from left to right, what happens? The
More
electronegativity
elect-
increases. Isn't it clear? Got it? Understood. So oxygen will be having more electronegativity. Is it clear? Fine. Did you guys think? Fine. So it will
Yeah.
be having, see, over here the negative charge is on nitrogen. In this, the negative formal charge is on oxygen. Is it clear? So which is the favorite? One or two?
One.
One. Understood. Clear? Did you get this thing easily?
Yes.
Fine. So it's a very important part, right? Now we are going to what? Now we're going to the part of the ozone depletion, right? Now mind, we have to understand a very important part next. That if we see the ozone layer, how does it help us? This ozone layer helps us in many ways. Why? See,
Filter from UV.
when we go up the atmosphere, what happens? The temperature starts to decrease, isn't it? When you go to a mountain station, what happens? The temperature decreases, right? If you go up the atmosphere, what happens? The temperature decreases. Is it clear? Fine. Is it clear? But suddenly what happens when you reach 20 kilometers, right? Suddenly there's a layer where there's an increase of almost 40 degrees centigrade happening, isn't it? Understood? Do you understand this thing?
Yeah.
This is called a stratosphere. Stratosphere, the other side of the layer is minus 62, right? When you cross the stratosphere, it's minus 18. Is it clear? Now
Yeah.
there must be something happening over here in this layer, right? Which will be making the 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 layer very hot. See, 40 degrees is getting increased. That's a huge thing happening, isn't it? In the stratosphere, right? What is the stratosphere? The stratosphere helps us to keep the earth warmer. Is it clear? Got it? Means some reaction is happening over here which is keeping our earth warmer. Is it clear? Understood this thing? Fine. Got it? Second, there must be some reactions happening over here which will be increasing the temperatures. Second, we know that ultraviolet light, isn't it? Ultraviolet light kills the body's cell. Is it clear? All the living cells, plant cell, animal cell, whoever. Is it clear? Fine. Whoever, plant cell, animal cell, whatever. Is it clear? Did you get this thing right? It kills the body cell. Is it clear? So ultraviolet rays, if it comes to the earth, then there will be no living organisms present. Is it clear? Got
Yeah.
it? In biology,
Yeah.
we learned that ultraviolet ray is kills any living organisms, plant, animal, whatever, single celled, whatever, algae, bacteria, anyway. So so something is there over here which is absorbing the ultraviolet ray. Clear? Got it? Understood? So we have to
Yeah.
tell two things, that how is the atmosphere over here getting heated up, right? Fine. Second, how is the stratosphere layer helping to absorb the ultraviolet ray? Is it clear to you? Got it?
Yeah.
Is it clear? Now in the ozone layer, what happens? This stratosphere contains oxygen and ozone, right? In a very fine balance reactions happening. Clear? Understood this thing?
Yeah.
Fine. Did you understand this thing? Now see, what happens? You have to see that whenever we are seeing oxygen, right? Oxygen and ozone. Now tell me how many bonds are there in the ozone? Ozone undergoes resonance, right? We learned ozone
Yeah.
undergoes resonance, right? Isn't it? Fine. Isn't it? Undergoes resonance. So it will be shifting like this, isn't it? Shifting like this, isn't it? Again shifting like this. So it will be having a resonance structure. Is it clear? Dot 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 dot
Yeah.
dot. How many number of bonds are over here? Mine can tell me.
1.5. 1.5.
1.5, isn't it? Very good answer. Quick answer too, right? It is having 1.5 bonds, right? Clear? Fine. Now remember one thing, that if it is having 1.5 bonds, right? How much bonds in oxygen? Two bonds.
Two.
Now can you tell me that which bond is easier to break? Ozone or
The
oxygen?
ozone.
Ozone, because it has got less bond order, right? 1.5.
Yeah.
So this will be needing lesser energy to break it. Is it clear? And
Yeah.
this will be needing more energy to break. Is it clear? Understood? Fine. Do you
Yeah.
guys think? Now we have to go to a formula we have to know. E is equal to hc by lambda. Is it clear? Understood? E is equal to hc by lambda. Got it? Is it clear? Fine. E is equal to hc by lambda. Did you get this thing clearly? Fine. Understood this thing? Now tell me one thing. If the wavelength of a radiation increases, the energy decreases or increases? Mine, you have to know.
The
Means
energy
you have to,
decreases.
energy decreases. You have to know these two formulas, right? E is equal to h nu. H is the Planck's constant and nu is the frequency. Is it clear? And E is equal to hc by lambda. Got it? Is it clear?
Uh,
Got it? Is it clear to you? Fine. Understood.
so what was H?
H was Planck's constant, right?
Okay.
6.16 to 10 to the power minus 34 joules per
Okay.
second, right? Very important
Yeah.
equation. You'll be needing this in the emission spectrum also, right?
Yeah.
Right? Is it clear? Got it? Now, if you see that whenever we are seeing the ultraviolet ray has got a wavelength region of 230 to 2 to 330. Is it clear? Understood?
Yeah.
It has got a wavelength region of what? Tell me. 230 to
330.
330, right? Isn't it? Fine. We have to show that this entire wavelength region of the ultraviolet ray is absorbed. Fine. Now, you beautifully told that if the wavelength decreases, the energy increases. Isn't it clear? So ozone needs a higher energy to break. Sorry, my bad. I'm keeping. Oxygen needs a higher energy to break, isn't it? Isn't it? Fine. So what happens? The first reaction is that oxygen will be breaking down into O dot and O dot. This is an endothermic reaction because this needs energy to break. Is it clear?
Yeah.
It's an endothermic reaction. Got it? It's need energy to break, right? Second reaction, ozone will also now break by absorbing the lower energy because it has got 1.5 lower energy region of the ultraviolet ray. Which is the lower energy region? Lambda of 330. We know that
330.
if the lambda increases, the energy, tell me, decreases?
Increase.
Decreases?
Sorry, decreases. Yeah.
Decreases? So it absorbs the 330 nm region. Is it clear?
Yeah.
This is also endothermic. Is it clear? Fine. Because it's bond breakage. Clear? Got it? Is it clear till over here? Fine.
Yeah.
The
Yeah.
third reaction which happens is that ozone will be reacting with the O dot coming on from these two equations and bond formation will be happening. Clear? And this is exothermic. What is bond formation exothermic or bond breaking exothermic? Right?
Formation.
Formation. This step is bond formation. Is it clear? Is it clear? And it
Yeah.
breaks. Sorry, and it is exothermic. This is hugely exothermic. And this will be releasing huge amount of energy. Is it clear? To
Yeah.
increase the temperature of stratosphere by 40 degrees centigrade. Is it clear? Got
Okay.
it? Is it clear?
Yeah.
Any questions, please tell me.
No,
So
so
we
understood.
understood that why the temperature of the stratosphere, which helps our Earth to keep warmer. If the stratosphere was not there, we would have been died in cold, right? Is it clear?
Yeah.
Moon does not have any stratosphere or atmosphere. Mars doesn't have any stratosphere or atmosphere. So there no life is possible because the temperature of moon when the sun goes down is minus 140 degrees centigrade. When the sun shines, the temperature of the moon is plus 120 degrees centigrade because there is no atmosphere there. Clear? Understood? Got it? What happens? The ultraviolet ray is also getting absorbed in this reaction. Can you see this? Totally absorbed. Clear?
Yeah.
Understood this thing? So you have to practice this reaction. Is it clear to you? Absolutely clear. Mine? There's no question over here.
No,
Clear?
so yeah.
Understood? Just 1 minute, mine. Just give me 1 minute.